our new unit is on describing data. So the standards in this unit will cover a variety of statistical concepts. We're going to start off today looking at quantitative data versus qualitative data. Next week we will look at histograms and using histograms as a way to display our continuous data. And then the next week we will look at two-way tables. The 2 days after that, two-way tables. And then next Friday, a quiz. So then we have Thanksgiving week off. We come back. We do a quick refreshing of measures of central tendency, mean, median, mode, range. Mean, median, mode. Measures of dispersion. We'll look at range and mean absolute deviation. Did you guys do mean absolute deviation?
Yes.
In
Somewhat.
grade?
Yeah.
Somewhat.
No.
Yeah,
Okay.
that's
I remember doing it.
All right. I just did it with my daughter who's in 7th grade just a few weeks ago. So maybe not, but I'll teach mean absolute deviation. It's a simple concept. And then we're going to look at box plots, dot plots. We're going to do scatter plots. And when we look at our scatter plots, we're going to look at our data. And we're going to find out ways to model that data. Now you guys have only studied two functions, linear functions and exponential functions. Most of the data we'll be modeling in this unit, we're going to model more precisely with a linear function. When we look at our linear functions, we're going to look at doing linear regressions, discovering the correlation coefficient, deciding if that is a strong or a weak correlation coefficient, therefore stating whether the linear model is a good model. And we're going to look at residuals, which is basically the difference between the real data and what your model predicted the data would be, and helping us to determine if the linear model was a good fit for your data. So that sums up this whole unit, and that's it for this semester. So that takes us all the way to the week before finals. Your final packet, I told you I uploaded yesterday to the website, so it is there for you to use. Now, every other unit I've printed a calendar out for you. I did not print this calendar for you. It is on the website, so let's go look at the website. And Ms. Morgan recently taught me how to embed everything on to my calendar. So here's our website, and do you see the calendar is here? On the Unit 5 tab, the calendar is here, and then down here I attached a PDF version of the calendar, so if you'd like to print one out, you certainly may do so at your
Isn't it
at
on the
home.
back of the last one? Ours is on the back of the last one.
I accidentally printed the wrong calendar on the back of the last one. Yes, I did. Okay, so what I'm going to do instead of putting lots of attachments down here at the bottom is I'm going to embed what we're doing into the calendar that's on that page. And let me show you how I've been doing that in my other class. Do you see all these links?
Yeah.
So what I've done is I've just said, okay, if you guys need the key for this lesson, I put it in the actual calendar instead of down at the bottom. So you can click on it and it'll be the key. Okay? So I'm also going to embed your notes every day into the calendar. So you don't have to hunt at the bottom for the right thing anymore. I'm going to start actually putting it into the calendar. And so, all right, so that'll be there for you, and you can always go. We are in Unit 5 once again on describing data.
What's wrong with the calendar you printed out on the back?
All the homework assignments are wrong. Like I literally picked a calendar from 2 years ago instead of this one. Oops. I don't know what I was thinking. Apparently I wasn't thinking. I was doing too much at once. So the correct calendar is available to you. It's just not the one on the back of the last calendar. Ideally it would have been. Okay, so today we're going to look at some basic stuff before we get into more specific things about data. Today we're going to study quantitative versus qualitative data. And I think I'm going to put my mic on because my voice is starting to hurt. Even though y'all are being very good and very quiet.
Must be the
I want to go home.
cold time flu.
Almost time.
You got some six nominations.
Okay, so if any of your friends are not here today, if they have left to go be extremely supportive of our football teams or our cheerleaders or whatever, that is awesome. You just share with them where they can find all the information and let them know that I embedded everything they needed onto the calendar and they can just print it out.
Why did they leave so?
Because it's really far away. Okay, so everybody just received a copy of today's notes. And let's take a look at them here. Oops, too far. So today we're going to study quantitative versus categorical variables. We have some essential questions here. So we're going to look at different ways to summarize, represent, and interpret data. When taking real-life actions, what factors are important to consider in determining which statistic to use to compare, how to graphically represent that, and how do we interpret what we've done. And why is technology valuable when making statistical models? We'll be using technology to create some of these. Have any of you guys ever used Excel to make bar graphs? Yeah? Okay. We can use our graphing calculators to make box and whisker plots. Have you ever created circle or pie charts online? Okay, so some of you have, some of you have not. So we'll talk about those things too. Alright, so we have two branches of statistics. We have descriptive statistics and inferential statistics. We're pretty much going to be in this one, descriptive statistics. And that involves collecting. And please bring your technology on Monday because I will be collecting data from you. I have a link at the top of my website to a Google form where I'm going to collect data on my students. And I'm going to use that data to create problems for you guys. Okay?
I don't have the phone.
I have extra, and we also have the pods here. If you don't have your own technology, that is totally fine. All right, so we'll be collecting, organizing, and summarizing our data when we look at different groups. Inferential statistics is where we take that data and we make decisions based on that data. All right, two types of data that we could study. Quantitative, that's our numerical values, versus categorical, that's our qualitative. Well, quantitative versus qualitative. And have any of you ever talked about this in science?
Yes.
Yeah. So we're already familiar with these. So I can use quantitative or numerical. Now these consist of numerical measurements or counts. This is generally things we measure or count, like scores on a set of tests. We would measure height, we would measure weight, we would measure temperature. Those all fall into the quantitative variable category. Versus categorical. That's our qualitative. That consists of non-numerical entries, so really categorical things. Color of a car, color of your hair, color of your eyes. So these are descriptive or qualitative data. Gender, the year you are in school, whether you're a freshman, sophomore, junior, senior. Okay, do you see how those are things we don't really count? These are categories you would be placed into. All right, so on the website, I have links to all of the sites I'm going to be using today. I was going to embed all these into right here, but it got really, really fat on this one date, so I'm just leaving them right here. Okay, so let's look at qualitative versus quantitative. So qualitative deals with our descriptions. Data can be observed but not measured. So things that would be qualitative: color, texture, smell, taste, appearance, beauty. So qualitative is looking at the quality of something. Versus quantitative. Quantitative deals with numbers. Data that can be measured. Length, height, area, volume, weight, speed, time, temperature, humidity, sound levels, cost, members, ages, things we can measure or count. So quantitative deals with quantity. Okay? So we're going to look at three different things in light of both types of data. Here we have an oil painting in example 1. What type of qualitative data could we take from this painting? Well, It's blue-green in color. Has a gold frame. It smells old and musty. Its texture shows brushstrokes of oil paint. It's a peaceful scene of the country. And it's masterful brushstrokes on this particular painting. Okay, so all this is the side of my brain that doesn't work as well. Here we go. This is my side. Quantitative data. The picture is 10 by 14. It has a frame that's a 14 by 18. It weighs 8.5 pounds. The surface area is 140 square inches, and it costs $300. So see, two different ways of looking at the same object. Okay? Example 2, a latte. Our qualitative data could include a robust aroma, frothy appearance, a strong taste, and a burgundy cup. Our quantitative data, 12 ounces of latte, a serving temperature of precisely 150 degrees Fahrenheit. The serving cup is 7 inches in height, and it costs $4.95. You must have gone to Starbucks.
Yeah.
Okay. My daughter does too. All right, example 3. So both of these are looking at the freshman class. So all of you are in the freshman class. How can we look at that and find qualitative data? So here we go. Friendly demeanors. Is that a good description of your class?
Yes.
What does that mean?
Civic. Oh, you're nice
Oh.
to each other. Friendly. Okay. Civic-minded. You like to help out.
No.
Yes.
You're environmentalists.
No.
None of y'all throw things on the floor. You're always taking your cups and putting them in the recycling and important things. Using both sides of paper. You're not wasteful. Okay. Oh, and here we go. Positive school spirit.
No.
Yeah.
Okay.
Right there.
So, all right. So Ian's on the right track. Some of you need to work on some of these things. All right, qualitative data. Now, these are not our numbers. This is bigger than your class. Your class probably has closer to 380 to 400 students. So we could count the number of students. We could separate them into girls and boys. We could give the percent of students that are on the honor roll, or we could give the percent of students that received a deficiency. You know, there's lots of different ways we can handle that. 150 students in accelerated math. Okay?
That's like less than a 4.
All right. So those are different ways that we can look at that data. Now, when we look at qualitative versus quantitative, our quantitative can be divided even further into discrete data, our countable data, and continuous data, our measurable data. So this quantitative can be divided even further. All right, here's an example of Arrow the dog. So, if we looked at some categorical qualitative variables, he is black and brown. He has long hair, and he has lots of energy. My dog has lots of energy too. Quantitative. We have discrete and continuous examples here. Discrete, he has 4 legs. He has 2 brothers. Continuous, he weighs 25.5 kilograms. He is 556 millimeters tall. So these are our measurable. This is what we count. This is what we describe. Okay, so we see all the differences? All right.
Why does it look weird?
He's running through the ocean water. Look at him. He's so excited. He's jumping.
He looks like he's gonna dive.
He looks like he's about to dive in. Maybe so. Maybe he's swimming in a lake and he's about to dive in.
Maybe
All right. Okay, so once we know what type of variable we're dealing with, how can we display this information? Well, our categorical, our qualitative variables, the things we're describing, we would use circle graphs, bar graphs, line graphs to display that data. So let's talk about a circle graph. A circle graph, you may have called it a pie chart. Your data is organized into categories for the purpose of comparing each category to the whole set. It shows the relationships of the parts to the whole, and generally as a percentage of the total. So let's go look at some of those. Okay, so our circle graphs, our pie charts, And you have seen these, haven't you? So here's our data. This is some of your friends, and this is the type of movies they like. And this is where we describe it. So we would have to total this up and find the percentage for each. So if we added this up, we'd see that there are 20 of your friends you must have surveyed. So 4 divided by 20 would tell us that comedy, 4 divided by 20 is 20%. 5 divided by 20 for action gives us 25%. So looking at the pie chart and looking at the data, you can obviously tell what most of your friends like. And looking at our pie chart here, you can also quickly see it's the biggest piece of pie versus the drama is the smallest. Okay? Have you guys ever created circle graphs? Okay, so here's a by hand way, which I probably wouldn't recommend, seeing that technology is so nice and easy, and you could do it that way a lot quicker. But we could find these percentages and multiply times 360 to figure out our degree measure and make one by hand if we were so inclined. I'm not so inclined at the moment. But here's another example of a circle. So this is our different categories for the grades in the last test. We have the A category, the B category, the C category, and the D category. Most of the students fell into the I got a B range. Okay. That's not my real data. Oh, that's the wrong name. Sorry. Okay, the next one, the bar or the double bar. This is where we take our data and we organize it into categories for the purpose of comparing the categories. The qualitative data is graphed using bars. The double bar or back-to-back bar graph is a special one that we use to compare two sets of data. So the double bar we would use for 2, the single bar is when we have one set of data. So let's go see what that would look like. So we have examples here of our bar graphs, and it's the same data. We're still going to the movies, it's the same data. So notice on these bar graphs down at the bottom we have all of our categories. And then we've titled it, it's our movies, and then we have our tick marks going up the side. We've labeled what each tick mark represents. They even put the numbers at the top of the bars. You don't have to do that, but you certainly can. If you have numbered it over here so we can tell what the counting units are, you wouldn't need to. But there's an example of a bar graph. Now, this is a different bar graph. We have more categories here, but it's still a bar graph. Please notice there's gaps in between. We keep gaps because it's not continuous data. It's categorical data. So we have different categories. We wouldn't want to smush it together because they don't really go together. Now, in a few minutes, we're going to look at a histogram. You'll notice the bar graph has our gaps, but the histogram has no gaps. And we're going to talk about why when we get to that in just a moment. Okay. So the next one after the bar graph is a line graph. And this is where we have data that changes over a period of time. So how it changes over time. Change over time. And if we had a double line graph, we're just comparing two sets of data. So let's take a look at what these look like. The line graph. Okay, so here's our time. Day 1, day 2, day 3, day 4. How did it change over time? Alright, so these are the facts you got correct about dogs. And as you continued to study, what happened? You got more right. It increased over time. Now, a double would just have 2 lines where we would be comparing 2 instead of 1. So you might have a line to represent Hayden, and then you might have a second line to represent Luke. Okay? And that's all it does, representing 2 different things. And that wraps it up for our qualitative, our categorical data. Now the next one is our quantitative. Now this is our measurable data. And we have dot plots, box and whisker, and histograms. Dot plots is a method where we visually display the distribution of data and where each data value is shown with a dot. And I think you guys may have done dot plots before. Let's look at a dot plot. You think you've done it? Awesome. So when we get to this part, this is data about how long it took you to eat breakfast. So obviously 6 people didn't eat it all. So when we have down the horizontal, we have the number of minutes it took, and vertically, each dot represents how many people took that long. So there's that data. Now, if we took the same data, we could turn it into a scatter plot. So this is still at 6, but we just don't see all the dots underneath. So if we just took that top dot for each one, we turn it into a scatter plot. Here's another dot plot with each one showing how many fall into each category. So those are our dot plots. Box and whisker. Box and whisker is a method of visually displaying a distribution of data using the median. Do you guys know what a median is?
All the numbers that.
It's the middle. All right? And then quartiles, this is where we look at, the median divides it into bigger numbers and smaller numbers, doesn't it? So if we find the median of the smaller number, that's a lower quartile. And if we find the median of the bigger number, that's the upper quartile. So I'm going to teach you how to do this. Some of you may already know, but for those of you that don't worry. I'm going to show you exactly how to do it. But this is what this would look like. Where's my first one? Here it is, a box and whisker plot. So this in the middle, this Q2 represents the median of the data. This bar right here where it says Q1, this is the middle of that lower half of the data. And this is the middle of the upper half of the data. Now the end right here is your highest, and the end down here is your lowest value. And that's how we create a box and whisker. We plot the lowest value, we plot the highest value. We put a bar for the median, and that divides our data. We find the median of the lower half, that's our Q1. The median of the upper half, that's our Q3. And we connect them. And I'll show you exactly how to do that when we get there.
Why do they make it so complicated?
It's actually not that complicated. I just said it really fast, so it sounded complicated. And we can tell a lot just by looking at that box and whisker about what the data does.
So you're just cutting it into quarters.
Yep. 25%, 25%, 25%, 25%. Exactly. All right, the last thing we're going to look at is a histogram, and that is something we're going to study, a histogram. Ours will have these 3 characteristics. The horizontal scale is going to be quantitative, and it measures the data values. On the vertical scale, it measures the frequencies. Now, our consecutive bars will touch, and let's take a look at the histograms. Because along the bottom, we don't have our categories. We have number ranges, and it's continuous. So do you see how this goes from 40 to 50, 50 to 60, 60 to 70, 70 to 80? And it continues. There are no gaps because it's not categories like blue eyes, green eyes, brown eyes. It's continuous. And so we have a couple different histograms, and I will teach you about histograms also and how to create a histogram properly. All right, so I did it again. That kind of sums up what we're going to look at today. Today you have some questions out of your textbook, and those of you that didn't bring your textbook, I have the questions ready for you to look at. And then you should finish before the end of the day.